My name is 𝑠𝑎𝑐𝑐ℎ𝑎𝑟𝑜𝑠𝑒 and this is my colleague Alexis Rosson. And the aim of this project is to analyze the first law of thermodynamics.
As we know, the first law of thermodynamics is a law of conservation of energy. It states that the energy of an isolated system is constant. This means this energy cannot be created or destroyed, but it can be transformed into various forms of energies.
This project consists of burning rocket propellant, which is a potassium nitrate and saccharose. So this propellant will be ignited inside this insulated flask that is connected by a proper tube, and that tube is connected to a balloon that will expand after combustion. In order to run a safe experiment, we are using a radio transmitter and a receiver and a gyro switch that is connected to a 24 voltage battery. Now once the gyro is switched on, the current will pass through this wire that will ignite this small filament which is made with this material. Now this igniter will start the combustion of the propellant inside this insulated flask. In the process, the balloon will be inflated. So in order to take the measurement of its diameter, we are taking this ruler as a reference. So basically a picture will be uploaded on SolidWorks in order to have a precise measurement regarding the balloon diameter.
In order to clarify what my colleague Avedis was saying, a simple test will be performed. We are going to see when we turn the switch on, the filament will burn.
To start this experiment, first of all, we are going to measure the mass of the initial mass of this bottle. So this is what we are going to do on the scale. As we can see, the initial mass is 113.9 grams. So secondly, we are going to scale 1.5 grams of this propellant. So first of all, we should zero it again and okay, we have 1.5 gram of this propellant. Now secondly, we are going to insert this igniter inside the propellant. And we are going to seal it with this tape. Finally, the igniter will be inserted inside this bottle and it will be closed, and we make sure that we have a snug fit in order to prevent gas leakages. So finally, the whole system will be inserted inside, will be insulated. So basically, we are using a wool to insulate the system, and this is the probe of the thermocouple, of this thermocouple, that is initially recording an initial temperature equal to 24 degrees, which is the ambient temperature. So we should wrap things here. Now, once the combustion is run, we should remeasure the maximum temperature. The maximum temperature should be recorded in order to use those data in our calculations. after running this experiment, we are going to remeasure the final mass of this bottle. So, as you can see, we have a value around 114.8.9 grams. So basically 0.5 grams of air was released from the combustion to the balloon.
The measurement of the balloon diameter will be determined as follow. So we open SolidWorks and we sketch a plane. Let's say the front plane. You go to Tools, Sketch Tools, and we upload the first test balloon expansion. So this was the first test. We set the reference line at 0, which is the reference ruler graduation, and the second line at 200 millimeters, which is 20 centimeters. So that's 200 millimeters, and we set this distance to be equal to 200 millimeters. Now, in order to get the diameter of the balloon, which is considered to be a sphere, we set 2 reference points and then we evaluate that distance. So basically the diameter of this balloon is 91.24 millimeters. We took the same procedure to measure the diameter of the second balloon for the second test, and the value is 92.01 millimeter.
After performing two different tests, maximum temperatures were obtained. The first one is equal to 69.6 and the second one is equal to 59. This difference in temperature measurement is due to many sources of error, such as the inaccuracy of the instruments used and some leakage and the heat loss that were not accounted during the calculations. The energy of the system is constant and it consists of 3 components. The first one is the change in kinetic energy, which is in our case 0. The second one is the change in potential energy, which is also in our case 0. And the last one is the change in internal energy of the system. And now we have Q minus the amount of heat minus the amount of work is equal to the change in internal energy.
Now the work can be calculated as the integral of PdV. The variation of pressure inside the balloon is considered linear for simplicity, and the change in volume can be get from the experiment itself. And regarding the change in internal energy, it can be calculated by m, the mass of the air escaped, times the specific heat of the gas, which is considered air, and multiplied by the change in temperature, which is the maximum temperature minus the initial temperature, which is the ambient air temperature.
Now, performing all these calculations, the amount of heat is calculated and it is used to determine the heating value of the propellant. يلا.
Hi, I'm Vedis Chamitra, and this is...
مش هاي. مش هاي.
much.